Hello, this is Noah Karen with the ECE 321 video problem. In today's problem, we're going to get three given systems, and then we have to solve for whether the system is causal and whether the system is stable. Okay, so let's get into it. The first one is h1 of t equals e negative 4t u of t minus 2. And because I'm not an artist, we're going to use MATLAB. And so with the unit step and the time shift, it's going to start at 2. But we're going to look for when t is less than 0. And when t is less than 0, we can see here that h1 of t equals 0. So therefore, for that reason, h1 of t is causal, so it is good. And we're going to check for stability. And so for stability, we're going to take the integral of h1 of t, and then there's the unit step, and we're going to take that's just going to be the bounds of the integral. And then let's just solve the integral. And then, so after you solve the integral, you're going to get 1/4 e negative 8. And so the magnitude of h1 of t is less than infinity. So therefore, h1 of t is causal and stable. And for h2 of t, it's going to be e negative 3t plus 2 u of t minus 1. And so let's look at the graph. And so for the unit step and time shift, this one's going to start at 1. But we're going to look at t less than 0 in this region. And then when t is less than 0, h2 of t equals 0. So for that reason, it's going to be causal. And for stability, we're going to take the integral again of h2 of t. And then the integral is, solve the integral, set the bounds. You know how it is. It's 1/3 e negative 9. And then so h2 of t, the magnitude is going to be less than infinity. So therefore, h2 of t is causal and stable. Okay, so let's do h3 of t. And h3 of t is not like its brothers because it is not causal. And that is because when, as you can see here, t is less than 0, it's going to be 1 for until negative 2. But when t is less than 0, we're looking at that region. Over here, it's 1. So h3 of t equals 1. So h3 of t is greater than 0 for t less than 0, so it is not causal. And then for stability, we're going to take the integral of h3 of t. And then, so h3 of t is the ut plus 2 minus ut minus 4. So since we have two of those unit steps, we can just set the bounds of the integral to just those two. So it's going to be 4 and negative 2 of 1, and the integral of 1 is t. And then so we just solve for that integral, and then we're going to get stable. So the magnitude of h3 of t is less than infinity, so therefore it's stable.